So this is a question about buffers, and it's taken from H432 from the OCR sample question paper. And the question we're going to answer is this one here. So to prepare a buffer solution, 75 centimeters cubed of 0.220 moles per dm cubed butanoic acid is reacted with 50 centimeters cubed of 0.185 moles per dm cubed sodium hydroxide. Calculate the pH of this buffer at 25 degrees C. Give your answer 2 decimal places. Show while you're working. So there are 5 steps to doing this, and we're going to work through each step at a time. And the first thing we need to do is to calculate the number of moles of alkali used. So to calculate the number of moles we get of a solution, we use N equals CV. So N is the concentration, which we get from the question as 0.185, times by the volume of the sodium hydroxide, which is 50, divided by 1000, because we need to convert centimeters cubed into decimeters cubed. So the number of moles of alkali that we used was 9.25 times 10 to the minus 3. In the next step, we need to calculate the number of moles of salt that were made, and because 1 mole of salt is made from 1 mole of alkali, and we had 9.25 times 10 to the minus 3 moles of alkali, we must end up with 9.25 times 10 to the minus 3 moles of salt, because 1 mole of alkali gives 1 mole of salt. The next step is we need to calculate the number of moles of acid that there were at the start, and for this we use N equals CV. So the concentration of the acid was 0.220 moles per dm cubed, which is the concentration. The volume of the butanoic acid was 75 centimeters cubed. This is taken from the question. And we divide by 1000 to get it into decimeters cubed. So the number of moles of acid that we had at the start is 0.0165. In the next step, we need to calculate the number of moles of acid that remained after neutralization. So how many moles of butanoic acid did we have after it had reacted with the sodium hydroxide? So we started with 0.0165 moles of acid. We added 9.25 times 10 to the minus 3 moles of alkali, and 1 mole of acid reacted with 1 mole of alkali. So the amount of acid that we had left is the amount we started with, which is this number, and from that we take away the number of moles of alkali, because 1 mole of acid reacts with 1 mole of alkali, which is this bit. And so the number of moles of acid that remained after neutralization is 7.25 times 10 to the minus 3. For the last step, we need to use the Henderson Hasselbalch equation, and this is the equation here. And it's pH equals pKa plus log to the base 10 of the salt concentration divided by the acid concentration at the end. There is one thing we need to work out though. So this equation needs us to use the pKa, but the question gives us the Ka. So to calculate the pKa, we take minus log to the base 10 of Ka, and the Ka from butanoic acid from the question is 1.5 times 10 to the minus 5 mole per dm cubed. So if we put this number into this equation, the pKa of butanoic acid is 4.82. We can then substitute that number, the pKa, into the Henderson Hasselbalch equation. So the pKa we've just calculated is 4.82, plus log to the base 10 of the salt concentration, which is this part here, divided by the acid concentration at the end, which is this part here. So if you put these numbers into a calculator, the answer you get is 4.93. So to answer the question is what is the pH of the buffer is 4.93.